machine learning and artificial intelligence, machine learning and data science, they have democratized it so much that anybody with or without technical knowledge, algorithmic knowledge, understanding the details can actually use it and get benefit out of it. So the languages that we are currently using, and especially Python, there are all libraries there. It's just drag and drop. You take something and drop in there. So kindly let me know. I can probably arrange a session, an additional session in the evening for showing it in Python, to set up the environment in Python, and work one or two examples in Python and show you how it actually happens. So you have to let me know in your comment box if you are interested in one session of this actual practical session, how you work in Python. So if you want to, there are reasonable number of faculty who want to see this. We'll arrange another session in the evening for only those interested people to go through those practical sessions. Kindly let me know in the comment box if you are interested. We will take it for you specially. Okay. Okay, there are few interests. One thing we can do is, in today's feedback form, we'll ask a question whether you are interested in the practical session. If you are interested in the practical session, that will be basic. You also have to set up a Python environment and run 2-3 programs to see whether it is working or not. So you would have to tell me, Deepali ma'am, will 5:30 or 6 work for you? Will 6 work for you? Okay. Okay. So at probably 6 o'clock, we'll arrange a brief session. Just in half an hour, if you can spare, they will tell you how to launch a Python, how to set up this environment of Python and run a couple of programs. And from there on, you will be able to easily do more programs. Okay, so that we will be doing today, 5 p.m. Okay, so a half an hour to 1 hour program, Vijay Bhaskar Reddy sir. Will 5 be okay for you? No, we go by democracy and majority rule. So can you please type here if 5 works for you, yes or no? Yes. Okay. 5 p.m. Okay. All right. So one session, Sai sir, let us do at 5 p.m. because many of them are asking 5 p.m. So let us do one session at 5 p.m. today, and probably if you are interested, couple of other sessions also we'll conduct in the evening. So today morning for the theory class, let us start off today's class. As I said, today it is how you define a problem statement for artificial intelligence and how you start solving these problems. Let me share my screen before I start. So whatever I'm covering now is an entire, probably I think it will be some 30-40 hours for you. Actually, when you teach in college, it is 30 to 40 hours. So I'm trying to put everything in a compact manner. So you will have to little bit explore it further. Say, for example, I tell you node and path, and there will be certain other small nomenclature which is very easy for you to understand when you start teaching yourself. The very, very easy part, and for a professor it will be much more easier. Those parts I am leaving it off. Okay, so today will be problem solving. So the problem solving in artificial intelligence means actually the so everything we define in the terms of what is the start state and what is the end state. So everything we define in both in this form. So what is the desired goal and what are you in the starting. So these are the two important aspects that we will have to know to define a problem. For the problem solving, the first thing you have to do is define the problem. So what we do after that is we design logical algorithms. There will be number of algorithms that we will be dealing with as part of artificial intelligence. The key thing that both faculty and the students have to master is to understand all these algorithms. And but the good thing is for students who are very good at data structures, this is very easy for them to understand. For faculty, it will be much more easier. But there is a small step-by-step way to solve this problem. Very similar, or you can say extension to your data structures, whatever you teach as part of data structures. So we design logical algorithms for the solution. We utilize polynomial and differential equations. So this is another mathematical concept, dear faculty, that your students have to understand both probability statistics, and then little bit of linear algebra they will have to understand, and calculus also. But if they understand these mathematical concepts very strongly, artificial intelligence is implementation of the understanding. That is it. So you probably have to emphasize the students to go through those basics of probability, statistics, linear algebra, and calculus, and executing them using modeling paradigms. So first is you will design the algorithms utilizing certain mathematical concepts and execute them using certain models. So that is all about problem solving in artificial intelligence. For many of this, say for example, you are trying to find the best, only one single solution. There might be only one single solution. 2 plus 3 is always 5. So you will have to find a single solution for certain things. For certain problems, you will be trying to. So this is called heuristic way of problem solving. That means you have number of methods of solving that problem. There are number of routes and paths to solve that problem, and you will choose the best way to solve that problem. So these are different kinds of there are different kinds of algorithms that we'll look into. The main aspects that you will have to consider in artificial intelligence problem solving are two: search and planning. We'll go in detail, but today and probably for this entire session, we will be covering only search. Planning is probably for another FDP session. If some college wants to start an FDP into planning, we can do. But for this 6 days, we will be stopping with search. Okay, so most common games and puzzles that we use, this is called toy way of learning toy. So there are certain representations of real world problems, toy representation you can say, certain representations of real problems which you can use and apply to the real world problems. So most common puzzles or games that we use to explain or understand real world problems that we can deal with artificial intelligence are chess and queen problem, traveling salesman problem, and water jug problem. So just chesses that everybody knows, but very complex for us to discuss now here. Got it, Sai sir. Probably you are traveling during that time. Yes, sir. We will be doing it once again, probably 6 o'clock. Another session in your choice timings, which will be 6 probably next day. So these chess is too complex water jet problem. Yeah, I will do that, Rajesh Khanna sir. I will be doing. So the end queen problem, traveling salesman problem, and water jet problem. Just wanted to understand if you are all aware of end queen problem. Do you solve this as part of your C and data structures? Yes. Shaheen madam, yes. Anybody else who knows end queen problem very well? Rajesh Kannan sir, yes. Okay, please type no if you don't know the end queen problem. Vijay Bhaskar Reddy sir did water jug problem also. Okay, so let us not deal with. Okay, okay, okay. So, people who already know this, please kindly bear with us, be patient with us, so that others will also know this a little bit. Okay. Okay. So here we have this. Let us take the water jet problem as everybody has asked. So this water jet problem is I have 5 liter one and 3 liter two. 5 liter jug and 3 liter jug, two jugs we have. Okay, and these jugs are like this. You cannot see. When I give this problem to students and certain people, they actually say I will mark on it and things like that. So you cannot see what is there in this 5 liter jug or the 3 liter jug. How much is there? You cannot see. And then from these two together, you will have to derive 4 liters. Okay. So there is a water tap which is continuous flow of water. There is I mean, like, you can keep filling this 5 liter one and 3 liter one. You can keep filling this because there is a continuous flow of water. That's the problem statement. There is a 5 liter and 3 liter one, and you will have to derive 4 liters one. How will we derive 4 liter one from 5 liter to 3 liter? Please unmute yourself and try to attempt how you will derive. So some of the professors already know this. So there is no, you don't need to churn your mind or break your head to solve this problem. For people who haven't gone through this problem or haven't solved this problem, can you please try to solve this on how to get 4 liter out of 5 and 3 liters and a tap with unlimited water? Okay, looks like nobody wants to attempt. Let me explain to you how this problem is solved. So what I'll do is I will first fill the 3 liters jug. 3 liters jug I will fill, and I'll pour into 5 liters. I'll fill the 3 liters and I'll pour into 5 liters. So when I pour into 5 liters, what is that I'm left with in the two? Let me go back. In the two jugs, what is the time left with in the two jugs? Please type. There is when we are learning, I mean, like, I think there will be problems, and all are matured people here. There won't be any, making fun or things like that. So people are all matured here, so it should be all fine. Please type what will be there in the. So first I'm starting with 0 and 0. In the 5 liter one and 3 liter one, I'm starting with 0 and 0. 5 liter one is the first one and 3 liter one is the second one. So I start with 0, 0. I'm filling 1, 0, 3. Hope you are all able to see this. Okay. So 0, 0, and then I made 0, 3. What I'm doing now, I'm putting the 3, 1 into the 5 liter one. So it becomes 3 and 0. Is this notation easy to follow? Whatever I'm typing, is that okay? First, I start with 0 in the 5 liter, 0 in the 3 liter one. Now I'm filling the 3 liter bottle. At that time, the 5 liter bottle is 0. Now I'm pouring the entire 3 liter bottle water into 5 liter bottle. So it is filled with 3. Yeah, it is filled with 3 and now this is 0. How much is free in this? 2 liters is still free in this because it's totally 5. When I put 3, how much is still free? 2 is still free in the 5 liter one. And in this, we are having 0 now. Okay, so what I'll be doing, I'll again fill the 3 liter one. I'm exactly having same thing like this. And again, I'm filling 3 liter one. Okay. Now, if I pour again this 3 liter one into this, how much will be there in this and how much will be there in this? Please answer, faculty. How much will be there in this? Okay, so Sailita ma'am has given me the answer. So now I have 5, Dr. Srikala ma'am, 5 and 1. So we will be having 5 and 1. Okay, now what I'll be doing, I'll be throwing the entire 5 out. And I'll be having 0 and 1. I'll be having I'll throw entire 5 and then I will have just 0 and 1. Now I'll put this 1 into this and empty this. So when I put 1 into this, how much is empty? 4. 4 is empty and here I have 0. Now again what I'll be doing is, I will be filling this with 3 liters. Okay. Now 4 is empty and I have 3 liters here. What I'll do is, I'll put the 3 liters into this. I will be having 4 liters with 1 liter empty and this becomes 0. So this is how I got 4 liters in the 5 liter bottle. Okay, so you will be probably able to, you might have to help your students to start writing these notations. So they have to, whenever they are given a problem like this, they should quickly be able to give a notation like this and solve this problem. So what did I do? I started with 3, filling the 3. So you can actually start with filling with 5. So you can do 0, 0, 5, 0, 5, you transfer into 2, then you will get 2, 3. Like this, you can start doing this problem. However, it is always possible you will get the answer because 5, 3 and you are asked 4. 5 plus 3 is 8 and you are asked 4. With multiple combinations, that confidence you will have to give to your students that with multiple combinations, this is just number theory. So with multiple combinations, you can always be able to get the desired number. Okay, this is one example, but when they go to different interviews and things like that, what will happen is they will be giving multiple combinations of this problem. It might not be 5, 3, it can be 3 jars, it can be 2 jars with different capacity, and they might be asking to bring out different number. So there will be so many things, but it is finally just playing with these 2 numbers so that you will really get this output. This is the water jug problem. So somebody asked specifically water jug problem. Is this clear, sir? Can you let me know if this is clear or we should repeat? Okay. Rajesh Kannan sir has asked and he is clear. All right. Anybody who is not clear, please type no if you are not clear. Okay, fine. All right. Got it. Now for Okay, now for the people who do not know what is n-queen problem, other people, please bear with the other faculty who do not know this problem and haven't solved this problem. I have taken this 8-queen problem. N-queen is generalized version. You can solve 4-queen problem, N-queen problem, 8-queen problem. You can solve any number of problems. But I have taken 8-queen problem for the simplicity's sake, and also a little bit of next step instead of just the 4-queen problem. So the problem is that I have 8 queens and I'll have to put them in this board, and the queens the queens are very aggressive. They don't like the other queens. So what happens is you should not have any other queen in any other neighboring cell, nor you should have them in the same row, or you shouldn't have them in the same column. You also shouldn't have them in the diagonally neighboring places. So this, the left, right, diagonal right, bottom, top, the same row and the same row and same column. You should not have any other queen. That is the problem. Okay. So how do you solve this problem? The first thing anybody will do is with brute force. You will first put your first queen in the first row and the first column. And from here, I will try to solve where I should put the second one, where I should put the third one. I will start from doing here. So I will put the first queen in the first row, first column. I have put it here. This is numbers. How many solutions I have got is this numbers. So I've got 12 fundamental solutions. Can any sir who knows or ma'am who knows the total number of solutions tell me what will be the total number of solutions for a 8-queen problem? How many solutions we can get for a 8-queen problem? Only one. Okay, so looks like there are quite few faculty, 92 distinct solutions. That's right, Sri Lakshmi madam. Yeah, Satya Sai also, yes sir, and Madhuri, true. There is 92 solutions that we will be having. Probably many of you must be knowing how you have got this 92. Let me explain how you will get 92 solutions. So as I said, you start with one and then you choose where the second one has to go. So here you can see those. Start with one and your second one will be either in 5 or in 6. Okay, and the third one will be in 8. Fourth one will be either in 6 or 3. So when you start with row 1, your queen 1, what you will be having is you will be having 2 solutions. With 2, you will have 3, 4, 5, 6, 7, 8 solutions. With 3, you are having 3 solutions. Like this, you will be having 12 solutions. I mean, like move this, place this in somewhere, place this is somewhere, place this somewhere. Like this, you do number of iterations, you will be getting 12 principal solutions. So which one you see here? You see this 1 and then 6. 1, 2, 3, 4, 5, 6. Then the third one is 8. 1, 2, 3, 4, 5, 6, 7, 8. And the fourth one is in 3. So row 5 has 3, row 6 has 7, row 7 has 2, row 8 has. Like this, once you fix the first one here, you have 2 kinds of solutions where in the second row you can place the queen in the 6th row, the 6th column, or in the 5th column. I have represented here this one. The number 2 solution is represented in this graph. But you can use the same queens in the 5th one, 8th, and then 6th. Like this, you can change this accordingly. So each row here represents one kind of solution. So the second row here is one kind of solution. Third row is one kind of solution. Like this, you have 12 kinds of solutions for this problem, how you arrange the n-queen problem. Okay. Now, how are you getting this 92? I'm just showing you 12. These 12 are called fundamental or principal solutions. These are the fundamental solutions. These 12 can be changed in certain ways so that you will get 92 solutions. How can you change this in certain ways so that you get 92 solutions? So these are the 12 solutions I have. Those 12 solutions are shown like this. So I'll just make it bigger for you to see. So solution 1 to 12 represented there are represented here. How you show those 12 solutions is shown here. So different arrangement in the first, second, third, all these things are different arrangements. How will you get 92 solutions of these 12 solutions is how, so what is that is I took this the top one, the first one. I took this first one. This first one is like this. My first queen is here, second queen is here, third queen is here, fourth is. So I just rotate the same reply. I'm not changing the queens. I'm just changing the representation. That means I am turning it around. Okay, I'll just ungroup it. And in front of you only I will give you so that it is easy for you to follow. So this one I'm turning it around to 90 degrees. Okay, I get a new representation. Then I turn another 90 degrees, which means from the first solution this is 180 degrees. I get another solution. I just turn it around in the another 90 degrees. It is 270 degrees. Obviously, we won't turn to 360 degrees because you will get the same one as this. So I have for each of these, I have these 4 rotations and plus another 4 mirror solutions. So if you take the mirror or image of this, just it will come reverse of this, you will get another 4. So totally for each of these solutions, you have again 8 solutions. So what you should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 into 8. 12 into 8, actually you should get 96. But why are we saying 92? Okay, we are actually getting 12 into these kinds of rotations plus mirror images of these rotations. I get 12 into 8, 96 solutions. But I'm saying I have only 92 solutions. That is because when you map all these things, what you will see is 4 solutions repeat. So you will have to remove those 4 solutions and then you get 92 as those solutions. Okay. So did you get how you got those 92 solutions? Faculty, please tell me yes or no. So, sirs and ma'ams, in your class, do you actually work out the 92 methods for the students? Do you show all the 92 methods when you explain the n-queen problem? Okay, I'm not getting the answer, but I just want to know, probably we can probably write down the C program. So just wanted to know, do the students work out these 92 problems and submit to you? Is it a question to them in their question paper or no? Okay. So expanding the queen problem. Just as I said in the water jet problem, there are so many different varieties of water jet problem, right? So in the water jet problem, so you could actually see in the entire water jet problem 5 and 3, and then I said there are so many other combinations that in interviews students will be given. If they go for an artificial intelligence interview or go to an interview in one of the FANG companies, I hope you know what is FANG company. Okay. So there are these FANG companies, which is Facebook, Amazon, not sure what, okay, somebody has typed. So Vijay Bhaskar Reddy sir, it is Facebook, Apple, Amazon, Netflix and Google. So these people, actually Microsoft also, I don't know why they banned M from this kind of companies. So these kind of companies, when they go, the students will be asked in interview various combinations of the problems that we are actually seeing, and also certain problems like there is a man and a tiger and the grass and a goat and things like that together. You will have to make them travel from this end to that end. So these kind of problems are all problems that you can actually define a statement for all these problems, and also define in a way that you can solve in a mathematical way. Okay, so you see that you can just expand it mathematically. You don't really need to calculate for the 8 queen problem, 4 queen problem, how many solutions are there, what are those solutions. You don't need to actually calculate. See, if you see this is the 8 queen problem, there are 12 unique solutions. These 92 solutions are just those mirror images and turning around. So if you take a 4 queen problem, this is what usually most of the teachers or even the faculty development, everywhere I have seen this 4 queen problem, which is very simple. Unique solution is 1 and total solutions will be 2. But mathematically, you can just expand to so many other, so many number of n queen problems. The resource, if you want to do research in such kind of thing, in our group, I will actually post the resources on how to calculate this expanding the 8 queen problem. How to expand the 8 queen problem? We can actually do using mathematical simulation. I will explain to you, I will give the links to you which you can actually practice. Okay, so yeah, okay, I have already put this, I forgot about it. What was the previous slide? Fine, so n queen problem resources are here actually. This, when I give this, you can have a look at it. The total solutions link is this. If you want to see the unique solutions, the link is this. There is a special thing called super queens and unique super queens. You can go through all the solutions in this actually. Okay. There is also a C program. If you have really brilliant students in your class, you can ask them to work on these C programs for solving the n queen problems. And the entire C program is given in this link. Okay, so please try this, dear faculty members. It will be really, really good churning of the mind to work out on this algorithm. But the problem is I usually see many students are struggling even to reverse a number and things like that. So, just raising the bar, give them these tough problems so that those reversing the string and those problems become very easy for them. Okay, so another problem everybody knows is the traveling salesman problem or the traveling couple problem. So there are lots of algorithms that we solve, and here you see the weights across 2 nodes from one place to another place. So most of the artificial intelligence classes and artificial intelligence textbook that you are actually prescribed usually discusses this one of these problems, which I will slowly introduce that problem to you. However, it would have been much easier for us to understand if the names of those cities were Indian or our Indian cities names. Okay. So anyway, how do you actually go to how to approach a problem, how to approach the solutions of this problem? So you will have to first define the task environment. So slowly we are moving into the syllabus as we have initially mentioned. This is mapped to the syllabus that you will have to teach intern in your colleges. So most of the syllabus you see here, we are covering step by step. We have covered what is artificial intelligence, history of artificial intelligence. We have covered agents and environments and various things about these agents and environments. We are now dealing with problem solving agents and search strategies. Today we will not be able to complete the search strategies. We will be able to do half of the search strategies, and tomorrow we will be doing the rest of the half of the search strategies. So today we will be discussing problem solving agents, and what are those what we have just discussed is problem solving in artificial intelligence. How do we do that? So problem solving agents and example problems and the searching solutions. So here is where we are. Okay, so the task environment, you will have to define your task environment. So the task environment, to specify a task environment, you should have a performance measure. How do I measure the performance of my task? Whether it is the most efficient way or not. What is the environment? Or first, for the performance measure, you will have to define how do you define something as a success. How do you define something as a success after your algorithm has been completed? Next, you have to define your environment. What are the actuators? What are the sensors? This is what you will have to define. We have seen yesterday what are actuators. So let us actually remember this. So that's why this piece. So in this taxi, this is a taxi. Can you tell me in the chat box what is the performance measure? What is the environment? What are actuators and what are sensors? Okay, speed. T is speed, E is road, okay. Distance to be covered, okay. Map, Shanta Rama. Can you please also mention whether you are talking about P or E or ARS? Distance to be covered, okay. Anybody else? Can you try? Performance. P is safety, okay. P is safety. Anybody else? Speed, okay. Sri Lakshmi madam says speed. Fast, okay. Okay, so it need not be one dimension. Tires, okay. Yes, yes, actuators are tires. Speed, actuators, steering as driver. Yes, now we are getting so many answers. It is similar to that. So performance measure can be safety. Somebody has said safety. Speed. Somebody has also said fast. Legal, comfortable, maximize profits. So I was looking at somebody who will say mileage. So it is your maximizing profits. That means you travel the minimum miles to reach your destination, and you'll also have very good mileage. Your car should be having very good mileage. And what is the environment? Sir has mentioned already, Vijay Bhaskar Reddy sir, that roads, traffic, pedestrians, customers, this is your entire environment where you are driving your car. Actuators, people have mentioned steering and wheels, actually, yes. Steering, wheels, accelerator, brakes, signals, horns are actuators. And then sensors are your cameras, sonar, speedometer, GPS, these are, and also actually most important is the sensors. Now, this is artificial intelligence world, probably we are talking about an autonomous car, but for us who are driving cars, mirrors are so important, and actually most of the people who are driving on the road do not use this particular aspect for driving, okay? But cameras, at least when it comes autonomous, imagine we are in a world where we are seeing that human driving is more dangerous than the driving of the autonomous car. We are moving towards that world. So it is very easy. It is very easy and actually very safe for an autonomous car because it takes care of all the aspects. The human is distracted so many times in this, and also does not like to follow the rules. So we are moving towards a world where autonomous car is more safer than a human driving the car. Okay, so we talk about now state spaces. It is very important that the state spaces are very well defined. You have to define the state space. This structured step-by-step methodology, for me as a programmer, it will be very annoying for me to go this step by step. But once a student or a potential person who works in the industry knows this step by step, they can write very, very efficient ways of writing code, and also say, I write the code and I go to, I write, I mean, Wipro, I write the code, I go to TCS, I leave it, the code to entire code to go to somebody to interpret. Okay, so when you go through these step-by-step things, the student, the fresher or whoever has come to take up that code will very easily understand how we are going step by step, and also we can write really very, very efficient kind of coding when we go through these definitions. The entire, I mean, like all faculty are told that you are not you are not giving the knowledge required for the student to perform well in the industry, which I totally disagree. The student and the faculty or the colleges have to lay these fundamentals very strongly, over which it is the duty of the student to groom himself to be suitable for industry on how he is using all these fundamentals properly. What I have seen is these students who have these fundamentals properly write very, very efficient code. Just start off understanding the syntax and write the code. These people cannot write efficient code first. And second thing is they cannot shift between languages. So a person who is a very good programmer, you cannot call yourself .NET programmer, Java programmer or Python programmer. You are supposed to understand the syntax and write code in any language. That is just a tool like a pen. Language is just like a tool or a pen. I really emphasize that all the faculty and the students should get these fundamentals very strongly before they jump into writing programs and coding. So here, I don't know, anybody who will disagree or anybody who agrees this, please type yes or no. Agree, okay. All right. Okay, also, dear faculty, I see everybody is from IT and CSC, but in my experience, I was heading an account for National Grid, which is one of the biggest customers for Wipro. And as part of it, there were almost 200 to 250 students, 250 programmers working in one project. And I would definitely say people from other disciplines, like say electronics and mechanical, also performed very well because they have an overall understanding of the machines, overall understanding of many other details that just a CSC student wouldn't be having. So if I mean, most of the CSC, IT HODs and people are now leaders in their respective colleges. So please try to introduce those software aspects to your other disciplines like mechanical and civil. Let them also learn, because there is not much difference between disciplines these days. All of them have to work together. If you take just autonomous car, there is mechanical, there is electrical, there is electronics, there is artificial intelligence, machine learning, coding, everything is there in that. So now the lines are getting blurred and everybody is supposed to know a little bit of or fundamentals of other things. Now let us go to the state spaces. You will have to define, you have to define what is a state space here with an example. Thank you very much for joining Archana madam, maybe Tripoli Tanuku. It is very much important for you, madam. If you see in all the US top 20 universities of the world, not just the US, artificial intelligence is part of Tripoli department. It has grown enormously in Tripoli department. Okay, so going back to this, the problem is to travel from ARADRR to Bucharest. I really very well want to present this in Indian or in Indian cities, but however, because everybody uses this, it will be useful for you when you in turn present to your students. So I've used this. So from here to here, somebody has to travel. Okay, so how do you represent this courses of action that doesn't make agent to reach Bucharest on time? You can reject. That is the only rule that you have. This is the problem statement. This is the rule statement. Somebody has to travel from here to here, and if it is not efficient, then reject it. That is the rule that you are having. Okay. Now going to the next one. Okay. So the state, there are certain terminology that we'll have to understand here. The state contains all of the information. Yesterday we have seen the environment and the agent. You have seen that, right? The simple reflex, goal, and in all these things determining the goal state. So you have certain agents which need the goal-based agent will need the information about the environment. It stores it, and based on that, it will make decisions. So here is where the state space is something where you will have the information necessary to predict the effects of an action. It doesn't mean that it should have entire omni details. You don't need to have the entire details as part of this environment. You need to have the information necessary to predict the effects. So you say to the student, I have seen this. You need to have all the information related to the that environment. The students start asking questions related, how about I don't have this, how about, so you don't need all those things. All what you need is information necessary to determine if you can reach your goal state. For your goal state, whatever is needed, you should have that in the state space. So what does the state space assume? The state space assumes that the agent has perfect knowledge of the state space and observe what state it is in. I can't do much more than that. Even as a human, I will assume that I can teach only that which I know. This is the knowledge. There is so much of knowledge outside it. I cannot list down entire it and start addressing, I don't know this, I don't know this, I don't know this. Even for you, humans, it is the same thing. So same thing here. The agent assumes that whatever knowledge is given to that agent or to the machine is the knowledge that is required to travel from point A to point B. from your start state to the goal state. It assumes that the agent has entire perfect knowledge required for that. Okay. The second thing the agent wants is the set of actions. That means if I know the knowledge, but what should I do? That if there is a signal, I'm traveling, autonomous car, I'm traveling. If there is a signal, what should I do? And once you get the green, what should I do? So these are the questions the agent has after it has knowledge. What are the actions that it has to take? So the second step is set of actions. The first step is knowledge. Second step is set of actions. The third step is there are certain tests, certain problems that have more than one goals. So it has also should have more than one goal states. The agent will reach one of these goal state and can also recognize the goal state. So this is the third one. And what is a solution? What do you call a solution? Is the sequence of actions the agent will take from step A from point A to point B. Entire sequence it takes to go there is called. Please tell the importance of hybrid learning interdepartment. Of course, Divya Mohan ma'am will be doing that. I will definitely incorporate that part in the next. So a solution is sequence of actions that will get the agent from current state to the goal state. Okay, so here my problem, if you see, is the robo is outside room R103 here. It is outside the room R103 and at the position O103. And the goal is to go to R123. There is R123 here. It has to go to R123. So these are all doors. You can open, close, and then go or go like this or go like this. It can go in so many ways to position R123 from room 103 to R123. So a solution is what? Is the sequence of actions that will take the robo from R1023, R123. Okay. So that's one problem which we have established in the form of the state spaces. Now there can be little more complexity here where the robo has to deliver to many people in these rooms, many items. So it has to do lots of work. What all work it has to do? It has to match. It has to understand which parcel is for which room and how it has to travel, where it has to go first, where it has to go last. So there are so many problems that this robo has, then it has to deliver in multiple rooms. Is it? My screen is not visible to everyone. Can you please type if it is not visible? Okay. Ma'am, if it is visible, looks like, please check your connection. So more complex problems need more information for the agent. This is our agent now. Now it has lot of parcels to deliver and lot of rooms. So lot of activity it has to do. The algorithm becomes tougher after this position. Okay. So this is our classic problem which you will all be teaching your students because it is in the prescribed textbook. And really love the textbook. That the textbook is really good, very, very. Sorry, yeah, okay. So it is a classic problem. Everybody uses this to explain to their students. The problem is to travel from RR to Bucharest. So the problem definition is first the initial state of the agent. How you define the problem. So these are the 5 steps somebody has to give you when they are starting a project or starting to solve a problem. So the first step is define the state, initial state, which is RR. And also please inculcate this nomenclature to them or the notation to these students, the possible actions available to the agent. Now if this agent is at A, What are the possible directions for ARAD to go to Bucharest? Arad, so it can go to Zarin, it can go to Sibiu, it can go to Timisoara. It can go to these three places. There are three options. So how do you represent that? Actions. The first initial stage, IN initial state is ARAD, and what are the possible actions in flower brackets? Go SIBIU, go Timisoara, go Zarin. So there are three different options that this problem definition has. One is initial state, next is possible actions. Third one is transition model. What will happen if you go from this place to that place? So result SA, this is the model, how you represent. What is the start? What is the action? So how you write this is result of the first initial state Arab and the decision to go Zarin first. In Arab go Zarin is you will transform yourself. That is why it is called transition. You will transition from this state of IN being Arad to IN being Zarind now. So what will happen? The initial state is transitioned from Arad to Zarind. So this is another model they have to write after they write initial state, possible actions, and transition model. Then what is the goal test? Now you have to check. You have moved from ARAD to Zarin. Is this your goal? You have to do a goal test. Goal test is what is the state? Now, is it your goal? No. What is your goal? Your goal is Bucharest. Okay, that should be your goal. What is your goal? The test case is the state. When you are representing the state, the initial state should now reach to Bucharest. That is your goal test. When you are here, IN Zarin, your goal test will fail. When you are actually IN Bucharest, your goal test will pass. So you will have to design your goal test. Then your path cost function. So this is what we have discussed yesterday with the first day with the example I love Hyderabad biryani. One man's weightage, the cost function works best, or the weights is I love my family. For her, love and family has become highest weightage path. So we give path weight to each of those. So each of these has a path weight which will determine you the most efficient way to reach from Arad to Bucharest. Okay, so the third step, the fifth step is the path cost function. This is how you will define your problem definition. So the state space is what you will have to remember, the nomenclature, the initial state. So what are all in a state space problem? The initial state, the action, the transition. These are the most important in the state space problem definition. And path is the sequence how you connect. So A, S, R, T, D. This is the path. So the student has to actually give you that nomenclature. So they might use the first letter, but A to B, B to C, C to D, they have to give that in their exam or in their test. They will have to submit you their entire path. So the solution to the given problem, what is the solution to the given problem is how you move from initial state to the goal states. But the quality of the solution is measured. What is the best kind of solution among all the solutions that one person can reach is the cost function of the path. Okay. So the optimal solution has lowest path cost among all the solutions. So a human will not or will never spend their time in understanding what is the optimal solution. For them, there is how their mind works is with their visual and their understanding and with their background of the route understanding, they can easily say, I want to go this route, this route, this route, because they're happy going that route. Cost function alone doesn't define the best route for the human. But for the machine, the cost function defines the best route or the optimal solution for them to the lowest path cost is the optimal solution for the machine. So why are we defining only search? Is the search only aspect of an artificial intelligence problem? Is it the only thing that we are going to do in search? No. Search problem in artificial intelligence means searching solutions. It is not something like a Google search. Okay, search here means searching solutions, how you search the best solutions. Okay, so and a few other things that you will have to understand is if you don't have any child nodes to travel, then these are called leaf nodes. These are the final. So the same arrayed one can go through these through, and then each one of these can go through. So what I have done is made that entire map into a decision tree format. Okay. Now it becomes very easy for me to calculate. How it makes very easy for us to calculate, we will be seeing in next few minutes. So if there are no children after this, below this, it is called leaf node. But here SIBU has further 4 child nodes. So it is called frontier. This is called frontier. Okay. So the search strategy, how you search is it will involve expanding, traveling to a node and expanding that node or the frontier till you reach the leaf node or you reach your goal state, right? That is about searching the solutions. Okay, so how do you find loopy paths? What will happen is there are certain things where it will again take you back to your array. Okay, so if you go here, there are certain things. You go from this to this, this to this, this to this. You will design a forever loop path, and your algorithm will not come back to a solution. It will not come to a solution. So there is something called loopy path, something called redundant path. What is redundant path? You come here and you go back, you again search here. That means you are traveling a path again and again to reach to some other destination. It becomes redundant path. Loopy path is a special case of redundant path which will never come out and is really headache for programmers because their program will never come out of with a solution. Okay. So what you do when you find loopy paths and redundant paths is how do you break it? How do you make sure your algorithm doesn't go into this infinite loop or doesn't travel redundant paths and keep adding to your cost? So how do you do this? Is you have to consider cost because the costs are given in this. Against each of these paths, there is a cost. So when you start counting the cost and there is an infinite loop, you give after 1,000 rupees of cost, don't do such, just break the loop and come out. So you can consider the cost. Your formulation of the problem statement itself will help you because you are saying, give me the least cost path for me to reach my goal. So take that as your cue and incorporate in that in your problems, in your solution, so that it will break when the cost is becoming enormous. Second idea is remember which states have been visited previously. So you will have to remember why I'm telling this. When we start going through search algorithms, you will understand why we are doing certain things in that search algorithm. So remember which states have been visited previously. So I'm already from Arad to Cebu. I went to Arad. Okay, this is an infinite path here again. Arad to Cebu, I went to Fagares, and Fagares to Cebu and Arad. Again, I keep visiting to Cebu and Arad. I don't want to go that. So remember the nodes that you have visited. You don't want to go to Fagares again and again and again. So you have to discard previously visited nodes. To discard the previously nodes, you will have to maintain your travel register. I went to this place, okay, so I don't want to go there again. I went to this place, so I don't want to travel again. So you will have to maintain, or your program or algorithm has to maintain a register which will always keep noting down on which nodes you have already visited, so that you don't visit again and again and again. So these are the two ideas: how you break loopy paths and redundant paths, also how you write efficient algorithms. Okay, so what is the time that we have just checked? 12:12. Okay, so another two slides I will give a break, and then we will go to depth first or breadth first algorithm for today. So searching for solutions, there are two kinds: uninformed search and informed search. What is uninformed search and what is informed search? I have given only three because in the limited time we can cover only three, but you will be having few more: depth limit, iterative, and bidirectional. Okay, this is just repeated, I will change it. But in informed search also you have couple of other kind of searches. In uninformed search, why are they called uninformed search and informed search? Uninformed search is just blind. Okay, you don't know anything about this problem statement. You just keep traveling all the nodes till you reach your solution or the goal state. Informed state or heuristic, it is called, this is called blind, because blindly you are going to all places and finding out. Okay, this is where you are applying certain thought process, certain information that you already have related to that state, related to that route. You have all the costs and also the best. You have this knowledge of how to travel based on the given cost. So you have these two things. Broadly, the search algorithms can be classified on uninformed search and informed search. So here we are going to discuss depth first search, breadth first search, uniform cost search. I am little bit skeptical. Probably this uniform search has to be in between uninformed and informed, because uniform cost search has understanding of the costs. However, it comes under uninformed. Why it is placed under uninformed, I'll tell you when we are discussing uniform cost. Informed search, you have greedy search, A-star search, and graph search. We will be going through this search algorithms step by step. And finally, you also have to know whether you have written a successful algorithm. When do you consider an algorithm is successful? When it is complete. That means you know that you can find a solution if there exists. Okay, then it is a completeness or test. Then it is an optimality test. Does the algorithm find the optimal solution? And you all must be knowing this in your data structures classes. You might be teaching them time complexity and space complexity. Here it is little bit different on how you treat time complexity and space complexity. How long does it take for the algorithm to find the solution is time complexity. How much memory is consumed in finding the solution? Here is where I see, dear faculty members, that other branch students are good at this, at space complexity. Adversarial search, informed search. I have to think and tell, Rajesh Kannan sir, I'm not expert at this. I have to think and tell about this. So time complexity and space complexity, these are the things. So for artificial intelligence sake, that is why I said it is little bit different. We use B and D to measure the complexity. B is the branching factor. That means how many branches you have is complex. You have to travel all the branches. And the next one is how much deep you will have to go, which is D. Okay. So these are the two items you will see for figuring out the complexity. What is the branching factor and what is the depth to go to the shallowest goal node. So these are the two factors you consider to measure the complexity. So give me 2 minutes. I need some water. In 2 minutes, we will start and complete breadth first and depth first for today. Okay, sirs and ma'ams. Okay, so I'm just looking at the numbers going up because we are ending and some of the faculty want to actually get the attendance. So I'm seeing the numbers going up. Okay, so let's go into this breadth first. So it will take me some time. What I'm going to do is today I'm going to buy this drawing pad so that I can explain to you while drawing. This is most enjoyable when we are drawing. So let me, I have to explain while typing this. Otherwise, I'll just have to show the entire screen and there is no fun of learning there actually. So let me explain it step by step here. What happens in it? That first, you will have to give this principle to the student, what principle we are following, so that they can remember that from their data structures this. So what is breadth first is we follow the Q and FIFO principle. Breadth first, as you see, as you know from what you see from breadth first you are going to cover the breadth. From the names you will be easily able to understand. Okay, from names you can easily understand. So you have breadth first and depth first. Breadth first is you are going to cover or the breadth first. Depth first is when you choose a node, you are going to go deep and deeper and deeper inside and going to cover the depth. So here what you see is first we are going to discuss breadth first. For a human eye and for all of us, this is very easy to see. Okay, A, breadth is BC, and next breadth is DEFG. So easy. What is difficult in this? It is difficult because going for we have the simplest form to understand first. This can become as difficult as possible. It need not be tree. It can be a flat structure. It can be multiple like the map that we have seen. It can be multiple things. So it is not as easy as what we can define with the human eye. So we'll have to go step by step to resolve this. When we understand the steps to resolve this simple structure and then implement those steps in those complex structures, it becomes very easy for us to understand. So here Q and FIFO principle, if we go here, this is called root node where we start, and this is level 0, this is level 1, and this is level 2. It is obvious, I understand all the faculty, but it becomes easy for us when we go to the complex structures. So now, as I said, you usually call this visited nodes or travel register where you have got. So the travel register is a new terminology that this faculty group who are listening can actually start using. Usually they call in the textbooks as the visited nodes. So in the visited nodes, what happens is, so first I have to go to A, that is the root node. I go to the root A. Now, what will happen in the next? What will happen in the next is, because this is breadth first, I will, and always choose left. Sorry, left-handers, because we are all majority. The right-handers are majority. We go in our own way. So sorry, left-handers. So what we'll have to do is, the root node, we'll have to travel first to left side, which is B. So what you write is, you will travel. So this is all I have typed beforehand. We don't have all these things beforehand. So first I have only A. So what do you do next? What do you do next is, this is the Q. Okay. Depth first we will use stack. This is the Q. For the Q we are taking first A and then this arrow. So what happens? I travel to A. I have to go to left. What is in left? It is B. So I go to B. And what I also do is, because I don't want to travel again and again, wherever I have traveled, I will mark it off. Okay, so B also I cross off because I traveled. you will have to write here, when you went to B, you will have to write what are the children or what are the child nodes of B. What are they? C and D. You have to note them. Though you won't travel, you have to note them first. Okay. Now I go to C, D. I note the, oh sorry, D, D, E. A, B, C. For A, I note B and C, which are A's child nodes. I will write B, C. Now I went to B. What are the child nodes of B? D and E. So I write D and E. Okay. So I went to B. In my travel register also I write off B, because you will be correcting student finally on his route. So you will just have a look at the travel register or visited notes and see, okay, this is the right path and he gets the mark. So you will have to keep filling your travel register also to check not to go again and again. So you go to A, write its child notes B and C. Okay, go to B, the left one, and write the child nodes D and E here. But however, this is following first in, first out principle. So where should you go next? You should go to C, because first in, first out. This is in already. So you go to C. And when you go to C, what are the child nodes of C? F and G. So you write in your Q, you write F and also you write G. These are your child nodes. Okay, but how you will have to go? Now you went to C, right? Also write C and also cut off C. You went C. And where you should go next? You have to go to D. So now you go to D. Okay. You go to D and mention here, I went to D, now I won't go D anywhere. So cut off D. Next, under D there are no child nodes. So after G, you need not write anything else. Similarly, you will travel to next where you will have to go, first in, first out, go to E. Complete E. Now E also doesn't have any children. I will update my travel register. E. Okay. E also doesn't have children. So go back to B. Go back to A. Now C. These are all gone places. So I don't want to explore it further. I have explored these nodes. So I won't explore it further. So I'll go back to B. It doesn't have any nodes which I didn't travel. Okay, I'll go back to A. Now it doesn't have any nodes that I have. So it has C. It doesn't have any nodes that I haven't traveled. But what is there in your stack? In your stack, you still have F and G that you haven't traveled. So you go to this and again you choose F, which is left, which is the left one you choose, and complete this. You update your register, travel register, and finally you also go to G and update your travel register. So you will submit the travel register, the student will submit to you, and that is how you get. So breadth first is Q and FIFO principle, and that one is easy. But coming to here, if you see E has H, F, G, D has G, but G also goes to E. This is a little bit tough. So what we can do is, please have an understanding about what we have done already in breadth first for this simple problem. We will do this problem tomorrow, and also we will be going to depth first using stacks. However, what I'm going to do is I'm going to buy, instead of struggling so hard to go like this, I will draw tomorrow and show to you. So there are, as we will be discussing, uniform cost search, greedy search, A star search, and graph search. Very easy. All of them are slight improvements over others. Depth search also I can quickly, for the simple one I can tell you right now. Depth one is nothing but you go deep first, not A, B, C. You go A, B, D. and then E, then go to the top, then go to C, then go to F and G. So depth first, you will go deep first, and then backtrack till you complete all the nodes. That is the depth first. However, again tomorrow for the depth first, this one will be little bit difficult. So the key is not having a look at it and saying it is simple. I can say in a minute how you will have to travel, but it is, the key is learning how to populate the stacks and the queues. You will have to push and pop from the stacks so that you can apply it very easily to the complex structures. Okay, so that is about it. So we will close it today at this point and go through all the algorithms of search tomorrow before we start off knowledge representation. So I will ask our guys to actually include a question that would you want to attend the evening practical session in Python? Anybody who is interested, if there are reasonable representation of people who are interested, we will conduct that class today. Okay, so thank you very much. Hope you have learned today too. Dear team who has put this, can you please ask a question? Do they need a practical session in the evening? Okay, once again, I would like to thank the sponsor for this faculty development program, the Novaram Institute of Engineering and Technology, HOD sir, principal sir, and also the secretary, Mr. Haribabu Garu, and all the Blackbuck team who are really trying hard to make this very engaging, interesting, and also useful to the faculty. Thank you so much. All of you, hope you had a good session. Thanks and bye. Have a good day, all of you.